Hi, everybody. I'm Patrick. Today, we're going to be talking to you all about the state of Git security with SLSA and Gittuf. So first, a bit about myself. I'm a PhD candidate at NYU. I'm a maintainer of the Gittuf project, and I'm also a contributor to TAF, which is based on the update framework. It's a framework that we're working on to help secure the legal code.
Thanks. Hey, I'm Aditya. I'm an engineer at Bloomberg working on software supply chain security things, and I'm a maintainer of a number of projects in the space, including Gittuf and SLSA that we're going to talk about today. So let's talk about source code security, right? Source code is the foundation of all of our software. Everything else in the supply chain comes after, right? We want to lock down our builds, but if the source code that's getting built is compromised, then we're in trouble, right? So yeah. And we've seen a lot of incidents over the years in the source code space that target source control systems and things like that. This year, we had an instance of a very popular GitHub Action repository being compromised, and one of its releases being overwritten to do malicious things. We've seen a number of GitHub organization hijacks and things like that. A few years ago, the PHP project discovered that their Git server had been compromised, and someone had pushed malicious commits into the PHP source code itself. Many years ago at this point, like a decade ago, Juniper discovered that someone had managed to change some source code that then meant that the attackers could decrypt VPN connections. Very bad. More recently, any Discord users in the room? Any? OK, so this is top.gg registry for Discord bots and things like that. That was compromised because the underlying GitHub organization that hosts a lot of its source was one particular user who had a lot of privileges in that org. Their account was compromised, and that led to all kinds of problems downstream. So the natural question is, what can I do to protect source code, right? And the answer tends to be, hey, use source code management best practices, apply security policies on source code, etc. And to think about it more concretely, right, there are a few projects in the OpenSSF that can help. At this point, towards the end of Open Source Security Con, I think probably most of us have heard of SLSA a few times. So that's one that we're going to talk about today. The other one, of course, is Gittuf. That's also part of the OpenSSF. So SLSA. SLSA stands for Supply Chain Levels for Software Artifacts, and it's a framework that provides incremental levels that an organization or producer of software can adopt to secure their supply chain. And one thing that is sort of unique about SLSA is that there's a real emphasis on evidence and verifiability of what's happening in the supply chain, and that the right things are happening and things are secure. But a couple of years ago at this point, SLSA version 1 came out, 1.0, which introduced the build track focused on how software gets built. And now we've been working on the SLSA Source Track, and in fact, the second release candidate for SLSA v1.2, which introduces the Source Track, was released this morning. So the Source Track, it extends SLSA to cover source security, and it sort of sets requirements for two key entities. One is the organization that's producing software, and what SLSA defines as a source control system, which is a combination of your version control system and other systems that sort of make up your source control system as a whole. And examples are you use Git to manage your repositories, and then you actually store them on GitHub, where you get a whole lot of other controls and things like that. So as with the other SLSA build track and whatnot, the source track is similarly structured in a series of incremental levels. Level 1 is very simple. It's use a version control system. It's really meant as an on-ramp to the rest of the SLSA source track. It's for organizations that may have more ad hoc ways of managing source currently, and you want to get them on a structured path of managing source so that they can then move on towards the other benefits. Level 2 is where we start seeing some more security properties come into the picture. There's a requirement about preserving the history and continuity of source changes, especially in specific parts of your repository. And if you think of it in the context of controls, it's hey, we should not be able to overwrite our tags, right? We just saw an attack a few slides back where someone was able to change one of the release tags and cause problems because they were able to ship bad code or malicious code. And it's similar to that, right? Like you don't want to be able to overwrite those tags. You don't want to be able to force push to your most important branches, if we consider Git here. And the other thing is you want to ensure continuity of controls. The controls that protect the history and continuity of your source itself, they themselves must be continuously applied, because when you think about it, source development is very recursive, right? Any change you make now, any revision you prepare today, it builds on the revisions that came before. So if they were, not subject to high levels of quality, then there's a very good chance that whatever you're building today is still problematic. The other piece, of course, is provenance, which is about attribution of the changes that, to those who made them, which really enables auditability of how source in that particular project or repository evolves. At the next level, sort of vaguely titled continuous technical controls, it takes a lot of the same ideas about, but sort of shifts the balance to the source control system here, in that it must enable applying organization-defined technical controls, right? Security controls over source. This might be stuff that the organization chooses to do themselves. The SLSA website has some examples, like automated testing and other quality tests, quality checks and things like that. But the SES must enable doing all of that, and more generally provide a way to ensure that these checks are all run over specific named references. And again, the named reference is capitalized. It's because SLSA as a whole tries to be agnostic of a specific source control system or a version control system. But in the context of Git, it really means your Git branches, your Git tags. And finally, at the highest level, we have two-party review. You're going to have two trusted persons to review these changes. And it's this requirement's set at the highest level because not all repositories, not all projects can meet it, especially in the open source world. So it's at the highest level, but it's really does bring a lot of value in the context of the code that gets shipped and the kind of assurances you can have with this guardrail. So a few slides back, I emphasized that SLSA is built on this notion of having evidence for all of these things, meeting these requirements, as well as verifiability. And what that boils down to is if you've seen other parts of the SLSA framework, like the build track, we have these notions of attestations. The recommended way to do it is using the in-toto framework. In build, you have the build provenance, and we have something similar for the SLSA Source Track. First, we have source VSAs. The VSA stands for Verification Summary Attestation, and it communicates the high-level security properties that a particular source revision, your git commit or git tag, meets, like what SLSA level are they at, and any other additional controls that an organization might have enabled, right? That's all sort of summarized in this attestation. Under the hood, you also have source provenance attestations that kind of give you more of the granularity, like the granular details about how a particular revision came to be and why. This is what enables you to reason about why a particular revision is at a particular SLSA level, source level. As an example, you can see this is pulled from the spec. This is like a VSA that says, hey, this git commit 9804D1, I'm not reading out the whole thing, in the Hello World repository. It's got a couple branches pointing to it. It met SLSA source level 3. And it also contains a reference to the policy that was enforced over that particular revision, so that you can cross-reference against the policy and ensure that the right controls were in place and things like that. So let's talk about meeting the SLSA source track. First, there's a tool called the SLSA source tool. If you were paying attention a few months ago when the first release candidate of the source track was coming out, it was called the SLSA source POC. What the source tool does is it applies SLSA source policies as GitHub rule sets. It distributes them, and you can actually enable them on your GitHub repository and use source tool to produce the attestations that, like the VSAs and the source provenance, to show how you meet them. And the other project here is Gittuf. And here I'll hand it back to Patrick.
Thanks, Aditya. So before I get into how Gittuf can help you meet the SLSA source track, let's take a step back and let's talk about what is Gittuf. So Gittuf is a security layer for Git that allows policies that can be verified by anyone who has read access to your Git repository. The reason why we've done this is because Git servers today are a single point of trust and therefore a single point of failure. If your Git server is compromised, any security policies that it enforces you can no longer trust. And this is also pointed out in the SLSA threat model, as you see threat C there to source code management. So some of the policies that you can enforce with Gittuf are, for example, branch and tag protection. You can say, hey, only Alice, Bob, and Carol can merge to main and create release tags. You can also say another policy such as all changes to main must be reviewed by at least 2 of Alice, Bob, or Carol. And you can also say that no one can force push to main. Likewise, Gittuf also provides file and folder protection. So you can say only the cryptography team is allowed to make changes to the signatures package, which allows you to say, OK, in our mono repo, each project must be managed by the team responsible for it. So let's take a look at a diagram of Gittuf in action. You'll notice this is something probably similar to how your workflow works today. You have a developer. They have some commit. They push it up to their forge. And then other developers pull it down. With Gittuf, all we do is we just add some additional metadata that is then pushed up to the forge and also pulled down by all developers. And with Gittuf, the forge is still able, if it runs Gittuf, is still able to adjudicate changes according to the policy that's set. But also any other developer can see whether or not your changes were compliant with policy. And interestingly enough, also you can tell whether your changes will be compliant with policy or not. So in this case, Gittuf enables everybody on that screen to verify changes. So Gittuf offers controls that allow you to meet the SLSA source levels. For example, you can enforce the policy of no force pushes to protected references. You can also track policy continuity. So an admin can't, for example, drop the policy to do something malicious and then bring it back up. And you can also require 2 or more code reviews to meet, for example, SLSA source level 4. And in order to communicate SLSA source levels, we need attestations. And Gittuf's default data model is, in fact, built over in Toto attestations. For example, we use these to capture code reviews, merges, and so on and so forth. And so underway, we have an effort to build Gittuf verification procedures that allow you to do SLSA source attestations for revision. And what fun would it be without a demo on this? So here we have a demo. I 95% promise you it will work. The other 5%, I hope it will work. So the first thing we're going to do over here is, just for a reference, we are running this on the actual Gittuf repository in which Gittuf is developed. We're not running this on a fake demo repository. So the first thing I'm going to do is I'm going to list all the rules that are active on the Gittuf repository. So if you give that a moment, you'll see that we have 2 rules. We have a branch protection rule that says one of the maintainers that's on the Gittuf project needs to sign off on a change. And we also have a protect releases rule, which protects tags. Now, I'm going to run git rev parse main. And that's going to give us the hash of the current commit on the main branch for the tip. Now, remember that, 9B802. Why am I asking you to remember that? Well, I'm going to activate our super cool SLSA source attestation generation feature, and I'm going to verify the changes to the main branch. And I'm going to write 3 things here. I'm going to write something we call a unified VSA. And I'm going to write source provenance as well. And now, give it a minute or 2, and it's going to verify everything, again, on the Gittuf repository on the main branch right now. Hopefully this works. And since no error was reported, the Gittuf repository itself complies with the Gittuf policy we've set for it. So now let's take a look at each attestation that we've written. So the first one is the unified VSA. And what the unified VSA does is it tells you the source it tells you the history of the entire repository and whether or not it complies with a certain SLSA source level. So in this case, you'll see that the git commit of the head branch is 9b02. And we see that our repository is in fact compliant with SLSA source level 3. Now let's also do, you'll notice if you have paid attention, the SLSA source attestation also captures the policy that was used, and we'll notice that the top of the GitHub policy is in fact 34360. So next thing I'm going to do is I'm going to show something called all VSAs. And this part of the attestation generates one attestation per commit on the main branch. In this case, we've had 126 merges to main since we've last updated the policy, or last created the policy for the Gittuf repository, and therefore we have 126 attestations, one for every commit. So now I'm going to extract the most recent one. And you'll notice it is, again, the same thing. We have the most recent commit, 9b802, and the policy that is, in fact, is 34360. And it is, again, passed according to SLSA source level 3. And for the last thing I'm going to do here is I'm going to show the source provenance for the latest commit. Now, this is actually two attestations combined together. The first one you'll notice has two approvers. It has me and it has a colleague called Yongjae. Since I'm a maintainer, the Gittuf policy on effect on the repository says that all maintainers, one of them at least must approve. So that's why you'll say, hey, we have two people approving here. Why isn't this L4? Gittuf is capable of capturing that only certain people are allowed to actually count towards your approval threshold, right? And the other attestation here captures our GitHub app attestation, which basically allows one to approve on GitHub and use that directly in GitHub. All right. So to summarize, there's a brand new source track for SLSA. It allows incremental levels to secure source, level 1, level 2, level 3, and level 4. It sets requirements for organizations and source control systems, and this is all evidence-backed using attestations. And on Gittuf, if you use Git, you can use Gittuf as your SCS to meet the SLSA source track. And we place the emphasis on verifiable by all. Your SCS is not a single point of trust. Anybody in the who has read access to the repository can verify your claims. Looking forward on the SLSA side, there is the build env track. If you want to validate the build platform itself, there's also the dependency track if you want to enable software producers to measure risk introduced by dependencies. On the Gittuf side, we have two major efforts we're working on. We're doing some research on read access control. So for example, let's say you have a secret you want to store in the repository. You don't want everyone to be able to see it. We're working on that, but also let's say you want to develop a patch under embargo. How can you do it directly on the Git repository without alerting everyone that there is a patch, a security patch being developed? And there is also attestation storage standardization, which I believe our colleague Billy is giving a talk on something related to Intoto next, so please do check that out. There is an IT that we have on this to standardize it. So you might be asking yourself, hopefully are asking yourself, how do I get started and involved with this? On the SLSA side, there's a community meeting you're more than welcome to join every Monday. There is the SLSA and SLSA specification channels on the OpenSSF Slack. There is the mailing list, and there's also the GitHub, github.com/SLSA framework. And on the Gittuf side, we have community meetings every second and fourth Friday of the month, excuse me. We are on the Gittuf channel on the OpenSSF Slack as well. We have a mailing list, and our GitHub is github.com/Gittuf. And with that, that brings us to the conclusion. Thank you, everybody, for joining us today. And if you have any questions, we'd be more than happy to take them.
There are mics in the middle if you want to ask questions.
Yes, if you have a question, please, there's a mic in the middle that you can use.
I have one. So I love how you're able to establish different controls for different parts of, like the monorepo example was great. Like you can have different requirements for each. But that also means that you could effectively end up with a repository that has different levels of SLSA for different parts of the repo. Like if you are requiring more approvers in one, it may be SLSA level 4 than another. And I was just wondering if that's something that you've thought and if Gittuf can handle it in the attestations.
Yeah, so the SLSA source level applies on a per revision basis. So it's a question of like, okay, it's in this branch at this point in time. What were the controls that were enforced and so on, rather than like the repository as a whole, if that makes sense, right? It's about a specific sequence of changes in that repository that, and then like if a particular branch or something has a higher level, then it would only apply to the commits in that branch rather than the repository as a whole.
You're asking me?
No, I'm telling you.
Okay.
Yeah, so it's because like the levels are mapped to revisions rather than
Exactly.
the repository as a whole. So different parts of the repository may have different controls, but you think about what level a particular revision's at rather than the repository.
Yeah, but there's also continuity, right?
Yep.
So, okay. All right.
I might have missed something in your question, so happy to take it off the stage. Yep.
Thanks, Patrick. Thanks, Aditya. Actually, I have two questions. The first question is, how does Gittuf work with source tool? You know, SLSA community has a source tool and also the source action, which allows you to check the SLSA level against the rule sets on the GitHub repository. So how does Gittuf work with source tool, or what's the difference between each other? And the second question is, can you clarify more on the forge, that concept? I noticed this concept, the forge, in your diagram. Yeah, thank you.
Sure. I'll answer the first one. How does it interplay with the source tool? So first, the two tools are intended to be kind of complementary. The source tool is very focused on enabling SLSA source policies for using, very specific to GitHub, like the protections that you get there, whereas Gittuf takes like the orthogonal approach of like, how do we embed policies in the repository itself and ensure that they're met? And like, we develop Gittuf itself on GitHub, and I think I see a world where we'd actually be using both. Like, we use GitHub branch protection and so on ourselves, and we should probably start piloting the source tool in the GitHub repository to say, hey, we're using the SLSA source policies. And at the same time, we can map that to Gittuf with similar, like Gittuf-specific policies, and to sort of get a trust but verify approach to the security posture. The other part of the question was like, how do they interact with each other? And I think that's where the sort of upcoming work that we mentioned towards the end there, and Billy's going to give a talk about right after this, is the sort of standardizing how we handle all of these attestations so that the different tools can pick up. So that Gittuf, for instance, can say, oh, I see an attestation that was generated by source tool via the action or whatever, and I can still use that in some way to verify against Gittuf policy and so on. So like the attestations themselves become sort of the interface for these different tools to interact with each other, and standardizing how we handle those attestations is a big step towards that interoperability. And your second question?
Yes, to answer your second question, excellent question. The Forge is just the centralized server that you push your changes to. So in most cases, it's either going to be GitHub, GitLab, Bitbucket these days. That's where you do all your, that's where everybody pulls changes from, pushes changes to. And in today's case, that's also where security controls are enforced. You'll have your GitHub, you'll have a rule, for example, it'll say 2 people must approve a pull request before it can be merged to the main branch. That's where you configure those settings.